In a previous video, I introduced a law which we can use when we're multiplying two indices together. That's linked below. Today, we're going to use that law when there's variables involved. So, let's begin. Now, to recap our last video, we discovered that when we multiply two indices with the same base together, we keep that base and we add the exponents. For example, in front of me, I've got two indices, a to the power of m and a to the power of n. The base is here, and we can see that we're multiplying two indices with the same base. So when we apply that law, we keep the base the same, so that a, but we add the exponents, the m plus the n. So let's start by having a look at the following. We've got a to the power of 3 multiplied by a to the power of 2. Now the letter a just represents a number that we don't yet know. However, that number will be the same throughout this problem. Now I'm going to show you two ways that we can solve this problem. The method 1 is going to be where we expand the problem first, then simplify it. Where method 2, we're actually going to apply the law to solve the problem. Now you'll see pretty quickly that method 2 is the preferred way to do it, but I'm going to show you both ways so you have an understanding of how method 2 works. So in method 1, it's asking us to expand and simplify. So when we've got a to the power of 3, that is equal to a times itself 3 times. And then we multiply that with a to the power of 2, which is a times itself twice. Now you'll immediately notice when we expand this that we've got the same thing multiplied by itself 5 times. And that's where indices come in handy. We can represent this by writing that same thing, that a multiplied by itself 5 times, or to the power of 5. Now if we have a look at what we do when we apply the law, we're multiplying two indices with the same base. So we keep the base and we add the two exponents, so the 3 plus the 2, which will equal a to the 5. So you'll notice that both methods get the same answer in the same number of steps. But let's have a look at when the problem becomes a little bit more complex. So here I've got 2a to the power of 2 multiplied by 5a to the power of 3. In method 1, I want to expand this and simplify. So when I expand this, this is equal to 2 times a multiplied by 5 times a times a times a. Because I've got multiply between each and every one of my steps, I can write this in any order that I want, but it's only because I've got nothing but multiplication. So I'm going to order it with the numbers at the front, so that's 2 times 5, and then collect the a's together. So that's times a, times a, times a, times a, times a. Now 2 times 5 is equal to 10. Then that is multiplied by a, and it's multiplying itself 5 times, so it's to the power of 5. Now that will equal 10a to the power of 5. Alright, so let's have a look at what happens when we apply the law. Well, when we apply the law, we begin by multiplying the two coefficients together. So that's going to be 2 times 5. Then, because we're multiplying two indices with the same base, that a, we keep the base the same, but we add the exponents. Now 2 times 5 is equal to 10, and 2 plus 3 is equal to 5. So this is equal to 10a to the power of 5. Now you'll find that both methods will arrive to the same solution, but method 2 is much more efficient in its process. So now let's take a look at one more problem. What if I have more than one unknown? So here I've got a to the power of 2 multiplied by b to the power of 3 times by a to the power of 3 multiplied by b. Well, let's start by expanding and simplifying this problem. This is going to be equal to a times itself twice, multiplied by b times itself 3 times, all multiplied by a times itself 3 times, multiplied by b. Now it's important to remember here that b is actually to the first power, but because it's to the first power, we don't actually write that down. Now, because I've got nothing but multiplication here, I'm going to reorder it by collecting the a terms together and the b terms together. So that is going to be equal to a times a times a times a times a multiplied by b times b times b, and then multiplied by that final b. Now you can see I've got repeated multiplication with the same base. So I'm going to keep that base, which is a, and it multiplies itself 5 times, so it's a to the power of 5. Then that is multiplied by b, multiplied by itself 4 times, so it's b to the power of 4. Finally, when I'm writing this in simplest terms, I don't need that multiplication sign, so that is equal to a to the power of 5, b to the power of 4. Okay, so let's see what happens when we apply the law. Now, because in our original problem there's nothing but multiplication between these unknowns, I'm actually going to reorder it a little bit so you can see what I'm going to do. So I'm going to reorder it by collecting the terms. So this is equal to a squared times a cubed times b cubed times b. Now you don't have to write this as a working step, but it'll help you see what I'm about to do. You'll now see that I'm multiplying a to the power of 2 with a to the power of 3. We're multiplying two indices with the same base. So we keep the base and we add the exponents, that 2 plus 3. The same occurs with that b to the power of 3 multiplied by b, which is b to the power of 1. So we keep the base and we add the exponents. Now this will be equal to a to the power of 5, b to the power of 4. Now you'll see with each method we do arrive to the same solution. However, when we apply the law, it helps us arrive to that solution in a much more efficient method. Now, I want you to give it a go. I want you to simplify the following questions, leaving your answers in index form, like I did before. I want you to try and do it using method 2 by using the index laws each and every time. Remember, you can use method 1 to check to make sure you've got the right answer.